All right, today we're going to be walking through Lab 5, which is talking about hypothesis testing and the interpretation of p-values. So the first thing we're going to do is revisit the main regression models that we estimated in Lab 3. The first one is looking at how government ownership predicts the number of deficiencies. And so I'm just going to estimate this equation where we use the reg command defnum, so the number of deficiencies is their dependent variable, and I'm going to be representing the public sector, so I use our gov variable here. Right, and so I'll estimate this command, and everything here should already be review from stuff that we've discussed in previous weeks, but what is new for this week is the interpretation of the p-value. Right, so paying attention to this statistic right here. And I have written down what the interpretation of this p-value is, right? And it is that we reject the null hypothesis and conclude that the mean difference for deficiencies between the public and nonprofit/private sector is not equal to 0, right? Or in other words, we conclude that public sector ownership has a negative effect on deficiencies, right? And that is consistent with our alternative hypothesis. The second regression that we ran was looking at how government ownership predicts the percentage of Medicaid residents, right? So we'll run that here real quick. And now paying attention to the p-value here, right, we see that it's greater than 0.05, so it's statistically insignificant, right? And I have this write-up of the interpretation here, right? And we would say we fail to reject the null hypothesis and conclude that the mean difference for the percentage of Medicaid residents between the public and the omitted nonprofit and private sector is equal to 0. Or, in other words, we conclude that the relationship between public sector ownership and the percentage of Medicaid residents is inconclusive, right? So we can't reject our null hypothesis of no effect, and so we conclude that it's inconclusive what the true effect is. Now, the next thing I wanted to do was revisit a comment that some students made in regards to some outliers in the data set regarding the nursing home hours per resident day variables. Right, and what we're going to first do is summarize those variables and notice, right, that these values here are clearly nonsensical. They just don't really make sense and they look very suspicious, right? And if you notice how much smaller the mean value is for the total number of nursing aid hours, how much smaller it is compared to these other ones, right? And then also what should be a red flag here is look how big these standard deviations are compared to what this measure is. Right, and so it seems that those three variables here, the vocational hours per resident day, the RN hours per resident day, and the total hours per resident day are what's giving us trouble. So the first thing we're going to do is generate copies of those variables. Right, and so I had already generated them earlier, which is why I got this message, but for those of you who haven't generated it, you should be able to do that with no problem. Right, and this will be the same thing here since these variables were already generated, but if they're not, right, when you run them, right, for me it says 0 real changes made, but for you, it'll be changing those cases that were incorrect. Right, and then we can run these regressions here that compare the original model or the original measure with the new measure that we created. Right, so we'll just look here at the RN hours per resident day. Right, so this was our original regression. Right, we see a unit increase in the RN hours per resident day predicts a 0.2 percentage point decrease in the percentage of Medicaid residents. Right, and that's statistically significant. Now look at what happens with our new measure that removes those outlier cases. A 1 unit increase in RN hours per resident day now predicts a 14.9 percentage point decrease in the percentage of Medicaid residents, right? And it's still statistically significant, right? So this is sort of giving you guys a real hands-on practical example of how consequential it can be if you have outliers that could be biasing your estimates in some ways, right? And then the final thing to pay attention here, right? We lose some observations once we make that adjustment. And so then the final thing that I want to do with this lab is give you guys another example of how to use the outreg command to make a regression table. And so what we're going to do specifically here is make a table that has two columns, one for the fixed measure of total nursing hours per resident day, and then another column with the original measure. And the first thing we do is run the regression, followed by the outreg command, right? And that goes outreg2 using, right? And then you set your path directory. This is the title of the document, comma, word se, right? And then we'll just run that exact process over again, but this time we'll use the different regression and we'll add the word append. And what that does is tell Stata to add another column onto the table we just made. All right, so we did that, and now what we're going to do is open up a new Word document and go to the folder that we saved our example document in. And right, if you did this correctly, you should get the two columns here, right? These two different regression models. And from there, you can go about formatting it however you please.